Hello everyone, welcome to Diagnostics by Rick. Today we will be starting off the case study series with a 2011 Dodge Journey 2.4 liter 4-cylinder engine. This vehicle has codes P0340 and P0016. The case study playlist will be more in depth than the 10-minute diagnostic series. These will cover all aspects of the diagnostic instead of just focusing on a small section. So let's jump right into it. The P0340 is a circuit fault for bank 1 sensor 1 cam sensor, and the P0016 is a fault for the bank 1 sensor 1 cam sensor timing. Both codes were stored in the PCM when I arrived. The shop had already replaced the intake cam sensor with an aftermarket part, and then replaced it again with an OE part from Chrysler before calling me. The codes still return, and I found out that they return much quicker with a warm engine, especially the P0340. The P0016 was harder to duplicate, but it would eventually reset if I ran the engine long enough. Before we go any further, let's look closer at the code description and test procedures. In all data, it says that the P0340 is for a fault with cam sensor bank 1 sensor 1. In fact, if you look throughout the entire test procedure for P0340, it only ever refers to it as bank 1 sensor 1 and never clarifies intake or exhaust cam sensor. If we look at information for P0016, it is the same. Definition of bank 1 sensor 1. And the entire test procedure only ever refers to it as bank 1 sensor 1 and never intake or exhaust. But they do give us a wiring diagram for us to use to determine which is which. Looking at the diagram, bank 1 sensor 1 should be a yellow pink, dark blue dark green, and dark blue gray. Bank 1 sensor 2 should be pink yellow, brown white, and dark blue and brown. So let's take a look and see what we have. I know these colors don't show up perfectly in these pictures, but the exhaust cam is pink black, dark blue brown, and brown white. The intake cam is yellow pink, dark blue gray, and dark blue dark green. That seems different from what the diagram showed. Let's put them on the same page. Okay, we're supposed to have yellow pink, dark blue dark green, and dark green gray on bank 1 sensor 1. Then pink yellow, brown white, and dark blue brown on bank 1 sensor 2. So it looks like bank 1 sensor 1 matches the intake cam colors perfectly, but bank 1 sensor 2 does not match the exhaust cam. This happens frequently. Companies like to change harnesses mid-production and don't always show that in the diagrams. You can usually find the correct diagram by going up or down a year. So we could check a 2010 and a 2012 and probably find the right diagram for this vehicle. But since we already have a perfect match for bank 1 sensor 1 being the intake cam, we can be certain that the code P0340 is for the intake cam sensor, which is the one already replaced by the shop. We can be certain, can't we? I mean, after all, it's a perfect match for one of the sensors. From my experience, I can tell you this is a bad idea. Sure, it's likely that the assumption is correct since all three wires match perfectly, but we need to find the correct diagram for this vehicle. I searched from 2009 to 2014 and none of the diagrams match this vehicle. Seems this vehicle does not exist. I quickly searched Mitchell, but it also did not show the correct diagram. So I decided to go to Tech Authority and get the diagram from the manufacturer. It still does not match. I searched Tech Authority by VIN and the diagram doesn't match. If you look, there's no pink-black wire on either of the two cam sensors. We definitely have a pink-black wire on our exhaust cam sensor. Now I'm beginning to wonder if I have the correct vehicle. It's time to double check everything. The engine looks original. The VIN on the dash matches the VIN on the door. It's definitely a 2011, but I did notice something. Made in Mexico. Well, since looking it up by VIN didn't work, let's try to look it up by year, make, model and see if we can find a Journey made in Mexico as an option. Well, there is a Mexico option for the DX model, which I believe is a chassis cab truck, but not for the Journey. I go up and down a couple of years and I still find no Mexico option for the Journey. But maybe I can try to find the right wiring diagram by going up and down a couple of years. Well, finally, after going up 2 years to the 2013 Journey on Dodge's website, I find a diagram that matches the wire colors we have. But wait, the 3 colors that we had matched Bank 1 Sensor 1 to the intake cam sensor now say those wires are the same as Bank 1 Sensor 2. The yellow, pink, dark blue, dark green, dark blue, gray match sensor 2 in this diagram. In the 2011 diagram, those colors matched sensor 1. This diagram shows Bank 1 sensor 1 colors matching what we have for our exhaust cam sensor. So which diagram can we trust? The one that has the wire colors that match only one of our 2 sensors, but it's correct for the year? Or the diagram that matches all 6 wire colors, but it's the wrong vehicle year by 2 years? And this diagram from a 2013 doesn't match the diagram in all data. Sure, I trust the OEM more, but nothing is adding up right now. At this point, I don't trust either, and I want more information. All I really want right now is to know which sensor is Bank 1 Sensor 1 and which is Bank 1 Sensor 2. As I stated earlier, All Data Info only talks about Bank 1 Sensor 1 and never clarifies which sensor it is throughout the entire diagnostic test procedure. Let's try the same thing on the OEM website. At first, it looks like more of the same. Just a description for the P0340 of Bank 1 Sensor 1. Even the code set criteria doesn't give any more information. Then you see this gem of a chart in the middle of the page. I want to zoom in on this one so you don't miss the utter brilliance of it. The intake cam variable valve timing solenoid is the Bank 1 position 1 cam solenoid. The intake cam phaser is also the Bank 1 position 1 cam phaser. But the intake cam sensor is Bank 1 sensor 2. The opposite is the exhaust, where the solenoid and phaser are both considered Bank 1 position 2, but the sensor is considered Bank 1 position 1. I don't know what the engineer that decided this was smoking, but I'm sure he enjoyed himself. While all data's code set criteria for the P0016 only mentions Bank 1 Sensor 1, Dodge is more clear on this code, and it specifically says exhaust cam. Well, that took a while, and we haven't even begun any testing at this point. I only know which sensor the code is referring to. I hope this illustrates the importance of making sure you have a good understanding of what a code definition is before you go too far down the rabbit hole. This shop had already replaced the intake cam sensor because the wire colors in the diagram in All Data and on Dodge's website match the intake cam sensor to Bank 1 Sensor 1 perfectly. Not only the wire colors, but the wire positions matched. So this was a very easy mistake to make. I mean, after all, why bother looking at the wire colors for the exhaust cam sensor when the code is only for Bank 1 Sensor 1 and you already know that it matches your intake cam sensor perfectly? I did search through All Data looking for any indication of which sensor was which, and I did finally find this picture here showing where Bank 1 Sensor 2 is located, but this is the only image I could find. There was not another corresponding picture for Bank 1 Sensor 1. So now we know which sensor the PCM is unhappy with. We can finally begin testing. Maybe I will get lucky and it's just a bad exhaust cam sensor and I can move on to my next job. But we know if that were the case, I wouldn't be doing a case study on it. When I first crank the car, both cams are in sync. The exhaust cam difference is hovering around 7 degrees or minus 7 degrees, bouncing around a little, but within specs because the sync pid is always good. The intake cam also looks good and is hovering around 1.5 degrees and not really moving much at all. By now the engine has been running for a couple of minutes and is beginning to heat up. You can see the exhaust cam actual position here and the cam crank difference pid here. This pid at the top shows that it's in sync. So let me play this and watch the actual and the difference PIDs. You can see the values over here on the right where the cursor currently is. And watch how they begin to drop slowly as the engine is idling. The cam position slowly starts going more and more negative until finally it drops off hard for a brief moment, picks back up, and then slowly starts dropping again. Right here it's going to pick back up, it's going to drop off until it finally hits negative 16.6, and at that point the code sets and it turns the check engine light. Once a code is set, these PIDs will no longer update. They stop updating, so they stop at the last value that they saw before the code set. So don't let this one fool you. If you see it not updating, it doesn't mean it's not moving. It just means that there's a code set, so it will not update these PIDs anymore. And that's why you see a flat line right here. As soon as we went out of sync, we get a flat line and it pretty much just stays. Let's clear the code and try that again from the beginning. I start with the engine off, and you can see that the RPM drops. The exhaust cam position keeps dropping lower and lower. So right here, our RPM starts coming down, down, down. The cam crank difference PID drops all the way to this point, and then it tanks pretty hard. It looks like it does attempt to recover. You see the sync state up here. It tries to recover and calls it back in sync, and then it drops it out again, at which point it just stays in the not synced. We've set a code at this point, so there's no more updating. So once the engine got warm and the RPM came down, the cam position began to move. But what happens if I keep the RPM high artificially with my foot? Here's engine RPM, right here. And you can see I held it high for a little while after starting. Cam difference stays solid around negative 4 degrees, as long as I hold the RPM high. But as soon as I let go of the throttle, the RPM begins to drop, so does the cam difference. It drops slowly at first, but then it tanks a couple times. Looks like it recovers, tanks again. What's really interesting is this part here where it just ramps down after recovery, and then looks like it tries to recover again and then ramps down. So the cam crank difference on the exhaust cam seems to be slowly moving to the point where it's out of sync, and then it finally codes, and at that point it stops updating. The problem would only happen at idle, and this was very repeatable, at least at first. It seemed like it was plausible that this was an oil pressure issue, although pressure is usually used to move the cams, so low pressure seems like it would only cause a fault when the PCM is attempting to change cam position, and it couldn't do it due to low pressure. Low pressure wouldn't necessarily cause it to shift at idle when they haven't been already commanded at some point. Maybe it could cause it to bounce around some. All things to keep in mind, but I think the next thing I need to do is really take a look at the cam sensor on the scope, but don't forget about oil pressure, because this could end up being an issue, and maybe somehow oil pressure is causing a problem with the phaser, or maybe the problem is the phaser itself and cam timing is really moving around when it shouldn't be. When I connected the Pico, I was actually surprised the signal's actually dropping out. This is not an oil pressure problem at all. We're actually losing a signal. I found this odd given how the scan data would show the exhaust cam position difference drop slowly and not just instantly drop out. Sure, there were some points where it would drop out hard, but most of the time it would just ramp down into negative values slowly. I can only surmise that this is how the PCM reacts to an erratic signal or missing pulses, or maybe just an occasional missing pulse. If we zoom in on a section that still has pulses, we can see the signal beginning to break down. Like, look right here. I don't think this is noise. It doesn't actually line up with the ignition pulse here. This one does, but this does not. I think this is the signal is beginning to break down. We actually even have an extra little pulse here. Let's zoom in a little more. So now you can see more clearly how the cam sensor is beginning to break down here. Here's our extra little pulse. Remember this part for later. Here are a couple more views from different parts of the waveform where it's definitely breaking down hard right here. It's becoming very erratic. And here's one from the intake cam sensor, and this is whatever the exhaust cam sensor is doing. In fact, this is so erratic. This really looks like a poor connection to me, maybe a connector issue. I think we need to do a wiggle test and see what kind of results we get. Let's try and get the glare off here. Let's reach down and grab this connector. There we go. Push, wiggle. At first, it seems like I have found the issue. I can make the signal come and go by wiggling the connector. But then it gets more and more difficult to affect the sensor in either direction. I can't seem to make it work or make it stop working by wiggling it, even though in the beginning there was a definite correlation between me pushing on the connector and the signal produced. So now I think it's probably not the connector, but rather the sensor itself. And me wiggling the connector is also flexing the sensor ever so slightly, which can sometimes affect it. You would actually be surprised how little pressure it takes to make a bad electrical component make and break contact if there's a problem internally. By now the engine has gotten fully warmed up and the code no longer takes as much time to set. If I clear the code, it resets rather quickly after I crank the engine. This information is about to be important, so remember this. Normally, I would just make the call here and leave because I don't want to wait around for parts to arrive and my job of diagnosing the vehicle is finished. But since I rarely get to take fixed captures with my scope, and I know that they have an aftermarket sensor sitting inside on the shelf because they already installed it in the intake position before they ordered an OE sensor to put in that spot. So I decided to go and grab the new aftermarket sensor and go ahead and put it in the exhaust location so I can get some repaired captures. I still had my scope connected, so I got in the car, cleared codes, and cranked the engine. Much to my dismay, the check engine light came right back on. The P0340 returned after just a few seconds of running. I look at the scope and my signal's good. I shut it off, clear the code again, start the engine back up with the same result. This time I watched the cam sensor signal from the moment I cranked the engine. It never dropped out, yet I still have a code. From the moment I start the engine, the exhaust cam difference jumps to 12.8 degrees positive, and it stays there. But look at actual position for the exhaust versus desired. Desired is steady 120 degrees, but actual is bouncing all over the place between 116 and 140. Remember I said that once the engine got hot, the code was setting much quicker. With the old bad sensor, I could not possibly know if there was a problem with the phaser or timing chain because the signal kept dropping out. But now we have a good signal and my values seem off. I'm thinking this could be a chain or a phaser, maybe a stretch chain. So I need to find a known good cam crank correlation capture to compare to mine. But first, I want to do a cleaning procedure since I already have the scanner connected and it only takes about 30 seconds. I was watching the cleaning process on the scope as the phase of the cam shifted back and forth a bit when I noticed something. The electrical noise on the exhaust cam signal seems to be a bit excessive. Some of them seem to be a bit fat for just ignition noise. I zoom in and can clearly see these 2 extra pulses are in line with ignition noise seen on the other cam sensor, but is this enough to be a problem? So I zoom in a little more. These aren't just noise. The ignition is triggering the Hall effect, and it's creating 2 extra square waves where there should not be one. They are not very wide, and in fact only last about half a millisecond. But compared to what normal ignition noise looks like, as seen on the intake cam sensor, this is clearly not normal. But the question is, can the PCM see a square wave that only lasts for 433 microseconds? I'm not willing to bet that it can. I'm sure this is abnormal, but I'm not sure it's enough to affect PCM logic. So where do we go from here? Is this a problem with the aftermarket sensor? Do you remember earlier when I said, remember this part for later? This is the first capture with the original exhaust cam sensor still in it, before I switched it with the aftermarket part. The condition was not happening nearly as often as it is now. Only 1 out of every 5 or 6 pulses would have this anomaly. But it was happening. Maybe it gets worse as the engine gets hotter? As I am thinking, I decided to go ahead and put the original sensor back in. Everything's accessible and it will only take me about 2 minutes to do it. The problem is there all the time now, even with the original sensor back in it. But I know this sensor is bad and will probably stop working as soon as it gets hot, so I go ahead and put the aftermarket sensor back in the exhaust position. As I'm doing this, I noticed that the noise suppressor connector was knocked off at some point. No idea how long it's been disconnected, but this capacitor helps reduce noise from the ignition coils.
For a moment, this was unplugged, so I thought that was my issue, but I plugged it in and it made no difference.
So I would have bet a paycheck on that one, but after reconnecting the capacitor, it made no difference at all. What are the possible causes? Ignition coils? Spark plugs? Cam sensor? Maybe. But we have the original cam sensor and the new aftermarket cam sensor both behaving the same, so it's unlikely. One thing's for sure, it is ignition noise. So maybe I can figure out which 2 coils are causing the issue. Because at this point, I really don't know if these anomalies are causing the check engine light in the P0340 or not. This could be just a red herring and the real problem could still be with just a cam phaser or a stretch timing chain. It's really a question of which is easier to test and where's my time best spent.
Alright, I'm going to unplug a couple of coils here. Let's unplug 4. If it doesn't die, 2. Pause and see if those anomalies are still there. And lo and behold, they are gone.
Coils 2 and 4 are causing the anomalies. But are they causing the code? I decided to clear the code and crank the engine with the 2 coils disconnected.
Alright, the glare out here is horrible. It's kind of hard to see. But I have coils 2 and 4 unplugged. You can see it's in sync. I'm going to plug number 4 in. come up here. As soon as I plug it in.
So now I know that the code is being caused by this anomaly on the cam sensor signal, which is definitely being caused by ignition noise. I can reproduce this repeatedly. I've tried a few things here. First, I just grabbed some aluminum foil, which I keep in my van, and I just tried to shield the sensor by placing some foil over top of the coils, but that made absolutely no difference whatsoever. Next, I swapped the coil and the spark plug from cylinder number 2 with cylinder number 3. I was very surprised when the problem stayed with cylinder number 2. It didn't follow the coil and the plug to number 3. So if it's not a coil and it's not a spark plug, I suppose it could be faulty wiring, but I'm not really sure how that would cause this issue on just 2 of the ignition coils. So maybe we do have a bad cam sensor, but the original cam sensor had the exact same issue. After thinking about it for a few minutes, I realized that I had one known good OE sensor on this vehicle, and it's in the intake position. The shop had replaced the intake cam sensor with an OE part from Chrysler. Since the intake and exhaust sensors are the same, I decided to switch them front to back.
Alright, now we've got the OE sensor in the back, the aftermarket one in the front. And we can see our signals all cleaned up now. What's odd is I thought the issue would transfer to the front, but it doesn't. Apparently, for whatever reason, it only picks up noise in the back. And I will upload these and show the waveforms so you don't have to deal with the glare.
Here is the capture with the OE sensor in the exhaust position and the aftermarket sensor up front. I'm really surprised that it doesn't pick up the same noise when it's in the intake position as it did when it's in the exhaust position. I'm not sure why that is, but I told the shop to go ahead and get another OE sensor anyway, because there's a good chance it will cause a problem in the future. Yes, you can still see some ignition noise, but it's no longer triggering the Hall effect of the sensor. This noise here is very normal, very typical when scoping a camera crank sensor. Here it is zoomed in, and you can see it's just a line, not a square wave. I can zoom in even more, and you can see just how small this little pulse is. In fact, I have to zoom way in to measure the pulse of the electrical noise. It's just about 13 microseconds. Compare that to the 433 microseconds of the pulse the aftermarket Hall effect sensor was making when the coils were triggering the Hall effect. Finally, this car is finished. Both intake and exhaust are holding steady. Always in sync, no codes. I let it run for a while I cleaned up my tools, and it never went out of sync again. Well, that was fun. I hope this points out why it is important to make certain that you understand what a code is for. This will prevent the wrong parts from being replaced. Though in this case, it's hard to point any fingers because the information was so extremely misleading, and I think most techs would have replaced the intake cam sensor because the wire colors match perfectly, and the information in ALLDATA and other aftermarket information systems, and even the manufacturer's website, didn't have the correct diagrams. So, tough job. Easy to get this one wrong. I also hope it shows that whenever you have a strange problem after putting an aftermarket electrical part on a car, you should keep that part high on your list of suspects. But wait a minute. The original sensor had the same noise as the aftermarket one. Well, I think the original sensor was not original. This shop did not replace it, but I'd be willing to bet that someone put an aftermarket sensor in it at some point. It did look fairly new, certainly not 9 or 10 years old like a 2011 vehicle would be. No telling how long the owner has been chasing this fault. I spent a lot of time on this car, due to the difficulty of finding the correct diagrams and information for the code on this particular vehicle, and then the anomaly caused by the aftermarket part added to my work. My assumption is the shielding inside the cam sensor is not as good as the shielding in a more expensive OE part. While some aftermarket parts work just fine, there are many aftermarket parts that do not work well, and they can cause a big headache for a tech trying to diagnose the issue. I probably caused myself some extra work because I forgot my rule about aftermarket parts, and that rule is guilty until proven innocent. As a mobile tech, a big part of my job is telling shops that the new part that they just put on a car and the stack of 5 other new parts they have sitting on the shelf are all bad and they need to get a new one from the dealer. The cost difference between aftermarket and OE parts is there for a reason. And it's not just greedy manufacturers out to price gouge. As a rule, OE parts are better quality, sometimes much better quality than the aftermarket components. Don't get me wrong, I'm not saying all aftermarket companies are bad. There are some good aftermarket parts manufacturers out there. They just don't expect that the part you buy for a 90% discount is going to be good quality. After all, if all aftermarket parts were bad, then those companies would be out of business and no one would ever buy the parts if they failed to fix 100% of the vehicles. The fact is, a high percentage of them actually do work, at least for a while. And when I say for a while, that is actually another issue I see with aftermarket parts, and that is their lifespan is typically less than the OE part. That may not be a problem for some customers that swap cars every couple of years, but for others it may really matter. In fact, oftentimes the shops don't even know because the customer will get rid of the car before the part fails. I always suggest to shops that they offer the customer 2 options. A cheaper option, which is the option they will get from almost any other shop they go to or call for a quote, or an option with OE parts that cost more. The higher price tag will give a better quality repair. You'll be surprised at the number of people that will go for quality over price. No, it won't be half, it won't even be close to half, but it will probably be more than you expect. Those cars will have an overall better repair outcome, and your technicians will thank you because OE parts not only tend to fit better, but also the tech rarely has to do the job twice, or 3 times, or 4 times, because it's a bad part out of the box. Even if the customer does want to do the cheaper option, try to avoid the super cheap aftermarket parts and stick with higher quality brand names like Standard Motor Products. I know everyone has a story about a bad part from almost every company out there, and when I say Standard, they say, oh no, those are horrible parts. But when taken as a whole, some aftermarket companies have a much better track record than others. And no, it's not fair to compare them to OE. After all, they are trying to fill the customer request of the same part for less money. To do that, corners have to be cut somewhere. The good thing about higher quality aftermarket companies like Standard is that they know where they can cut corners and get away with it and where they can't. Now, I don't have any stake in Standard Motor Products. They're not a sponsor of this channel. I only, from my experience, have seen that they make pretty good quality aftermarket parts. And no, they are not the only good quality aftermarket parts supplier out there. I'm just giving you my opinion on what I have seen in the field. A good rule of thumb is this. If an OE part costs $100 and a good quality aftermarket part costs, say, $60, then you find another aftermarket part for $15, I would stay away from the $15 part unless you don't value your time or your tech's time. These super cheap parts generally cause more problems than they solve. Well, that wraps up this case study. If you enjoyed it, please hit the thumbs up and subscribe button. If you want to help support this channel, you can do so through Patreon. I'll leave a link in the description below. Even a small commitment helps me spend more time working on the channel. Thanks everyone, and have a good day.